So what we're going to do today is, again, we're going to have two halves of the session. The first one will be sort of creating some building blocks so that you can work with both image manipulation, but also some more advanced, not necessarily advanced, but some of the more wheels and cogs of Python to making your own programs. And then in the second half, we're going to look at a couple of images in some more detail and sort of think about what we might want to do in order to use all the tools we have at our at hand to really facilitate our research. So the first thing that we're going to do today, however, is we're going to start with just Q&A or catch up based on yesterday's session. Now, yesterday's session, what we ended up doing was taking a text file from the internet, so downloading that text file and processing it so that it was all in lowercase, that the punctuation had been removed. And then we made a list for each one of those words to find out how often it appeared, as well as when did it appear within that text. And in the end, we were able to use matplotlib in order to make a visualization of the range of instances, as was very accurately described yesterday, just like an ant conc, which is a standalone piece of software you can use for making concordances. So that's sort of my encapsulation of what we did yesterday, but we did go through a lot of code. So if you have any questions or would like anything clarified or gone into more detail from yesterday, this is your chance. Okay. I had a look at the graph options. Some are scarily odd. Yes, that's actually kind of the beauty of matplotlib, because it's open source and it's been improved by so many people who have just added what they needed over time, that there are a huge number of options available. Literally, you can kind of, if you can imagine it, you can do a visualization based on your data, and it is much, much more flexible than Excel. So that's been really, really fun for me to play around with as well. Okay, so what we're going to do today then is we're going to start with some nuts and bolts about Python, just so that I don't lose you later on in the development of this. So the first thing I want you to do is I want you to open up your Jupyter notebook and to open up a new Jupyter file. So you don't have to open up the same one you had yesterday. In fact, it's probably better that you have it as a different day, just so you don't get things confused. So I will just share my Jupyter notebook with you guys and keep that chat window up so I can see if you have any questions. Okay, so the first thing I want to talk to you about is the way that Jupyter Notebook is running Python, and the way that Python is run more generally is that it is done mostly at runtime, which means unlike some other programs, you don't have to write all of Python out, compile it into machine language, and then run it where you can't access it. It does run it essentially line by line. Now, that doesn't mean you can't do more object-oriented programming, which is a lecture for another day. You don't have to do it just in a step-by-step the way we've been doing it previously. You can do it in a much more modular way, where you write essentially a little factory that sits over here and it does one thing, and then you can call or go over to that factory whenever you need it, instead of having to redo it over and over again. And those are called functions. Now, we've been using lots of functions. So when we used len, for example, so the length of this list, oh, forgot those have to be strings. When we do the length of this list, it's 3. And that len is actually its own function. It's its own little program that we are calling, that we are asking to do something for us. And we are putting in a parameter. And the parameter for len is a list. And that's what it's called for. But you don't just have to use the functions that Python has as standard, or that you import from a library. You can actually create your own functions or even your own libraries when you get to that point. And the way you do this is fairly simple. So what you want to do is do def, which is define or definition. And then you want to call your function something. So my function. And then you want to put in these curved brackets. Sorry, they're called parentheses in the United States, and I'm trying to use British language. These parentheses, and then a colon. And everything that you put under here now, just your line by line code, will get run, will get done when you call that function in the future. So if we make a really simple function like print hello world, nothing will happen, but it does put that function into memory. So if I create an entirely new window and I run my function, again, you still need those parentheses, it will do what I told it to do. And it doesn't matter if this is an hour later or 600,000 lines of code later, as long as it's in memory, it will run. So you don't have to keep cutting and pasting the same code again and again. You can just save that and have it run just once at the very beginning of your program, or save it as a separate file and import it the same way you import anything else. One thing to remember, though, is if you want to have it take an input, you need to put those inputs into the my function. And in the way that you put the inputs in is you want to make it clear what those inputs are supposed to be. Now, you can name them anything you want. You can make your function, my function xy, and then have print xy. Now, if I try to run this now, it will give me an error. And the reason it gives me an error is it says that my function is missing two required arguments, x and y. And that's why it's helpful to actually name those things, something that you can remember or something that gives you a hint of what it's actually asking for. So if I name this instead, first name and last name, and then here I wrote, hello, first name, last name. Again, run that to put it into memory. If I do it again, I still get the same error, but it says this time that I'm missing a first name and a last name. So I can do that here. I can say Melodee and Wood. And now it puts those variables into the string expression. And this is really, really helpful for some of the things that we're going to be doing today, just to have this sort of functionality. So is that clear to everybody? That's sort of how you make a basic function that you can use in the future. So the other thing that we might want to do is we might want to ask the user or ask ourselves something while the program is running. So yesterday, when we were downloading that Gutenberg file, we went directly into the code and we put in that URL. But maybe we don't want to do that. Maybe we want to be able to use that program again and again, but put in a different variable every time, a different URL, a different string, what have you. So here, let's try this again. So instead of first name, last name, we are going to put in input and in brackets. And hopefully, okay, we can't do that because that'll require a lambda. So what we actually want to do is we're going to do a couple of nested functions. So we're going to leave this the way it was. And then down here, we're going to do first name equals input, last name equals input, and then my function, first name, last. Now, if I just do this now, it's not going to give me a very clear idea of what the computer is asking me. So you want to put in your question for the person who's using it within the brackets of input. So I'm going to say, what is your first name? Space, so that doesn't get all smushed together. And what is your last name? Now, if I do this, it's going to run these 3 bits of code, my input for my last name, and then running my original my function. So if I run it, you see I now get a input window, and I say my name is Melodee. My last name is Wood. Hello, Melodee Wood. And it all runs sort of within the screen. If you were running this outside of Jupyter Notebook, if you were just running it through Python normally, it would either run in the console, or if you had hooked it up to some other graphical interface, it might come up as a dialog box on the person's computer. So you can actually have your own little console type program where you input information and things come out. And it really doesn't matter what type of thing you do. So let's say I'm going to do this over and over again. So I can actually make this its own function, second function. But this time I'm not going to require any inputs. So if I go into here and I just say second function, it will run this function, which asks me for my name and my surname, and then runs this function up here. So you can actually layer them together in interesting ways to make your workflow work for you. You don't have to write everything from scratch in one giant list every time you do it. And you can have it ask questions. You don't have to rely on it simply being written from scratch every single time. So why don't you just take a second, if you've not done so already, and create your own little program questionnaire for yourself. And we'll start up again in about 30 seconds or a minute to make sure that's gone through. And if you could just give me a thumbs up if it's working great for you, that would be nice. So hopefully that works for everybody and you've got that sort of basic building block. So today, what we're going to do is we are going to be working mostly with images. And I wanted to make sure that you had an image that you can work with. If you've already put your own image into your working directory, as long as it's a JPEG, that's absolutely fine. If it's a GIF or a GIF, that could cause some problems, but we'll stick with that today. So before we get going, we do have a couple of libraries we have to import. Now, Python is absolutely great for plain old data, text, numbers, that sort of thing. But when you want to be using something a little bit more complicated, you do, generally speaking, have to import a library that can sort of handle that more complicated data. And there's a couple of different libraries we're going to use today. We're just going to install them all right at the beginning. But I will make sure I reference them as we go along so you know what we're using when we're using it. So the first library we're going to use is going to be requests, which is something that we used yesterday in order to download from the internet. Now we're only going to use this once, but it's good practice. So import requests. The next the next 4 that we're going to use are all about image manipulation. Now, the first 2 you have used before. We want to import matplotlib.image as matplotimage. Imping. Oh, sorry, impin, I can't pronounce that. But it's matplot image is what it's short for. And we also want to import matplotlib pyplot, which is the one we used yesterday, as PLT. So this first one is for interfacing with the internet. This one is for image manipulation in matplotlib. And this is for charts in Matplotlib. And the next one we're going to want to do is called the pillow library. So we're going to use the pillow image manipulation, which will let us do some more advanced image analysis. So from PIL, which is short for pillow, import, and we're going to import two different libraries here. But instead of doing that like we did up here as two different lines, I'm going to show you how to do it just on one line, and that's just image and image ops. And that will import both of those libraries into our system. And finally, we are going to import image.io, which is used for one very particular sort of save and manipulation that we're going to do. So those are the 5 libraries we're going to be using, and hopefully that will give you a good range of things that you will be able to do in the future as you work through your various image manipulations. So we're just going to run that and make sure all of them go into memory, and then move on to our next file. So the next thing that we want to do is we want to actually get our image. Now, what we want to do is we want to download an image from the internet. And we do that basically the same way we download a text image, with one little difference. So the first thing we want to do is make a variable to hold our image, and we're just going to call it image data, very, very creatively. And then we're going to use requests.get. And then inside get, we're going to put the URL. And I'm going to put that in the chat for you, just so that we're all using the same URL. And you just need to put this into quotation marks, whether single or double quotation marks. And at the end of this, when we were using a plain text file, we used .text, but this is not a text file. So we need to tell Python what type of file it is, and we do that with content. The next thing we're going to do is we are going to save this file to our workspace. Now, the reason we're doing this is we're going to be messing with this image a lot, and we kind of want to have an original copy of it on our PC or on our Mac that we can always go back to if we, make everyone's face black by accident or something like that. If we cut too much off, we want to have the original kind of safe without having to rely on the internet still working at that point. So the next line that we're going to do is we're going to take that data that's in the memory of our computer, and we're going to save it to a file. So with open, and the syntax here is sort of a standard way of telling something to open or create a file on your computer, keep it open, stuff data in it, and then close it down. That's sort of how you have to imagine it. So with using the function open, and what do you want to open? You want to open or actually create, in the process of opening, original image.jpg, and it does need to be a JPEG in this case. And put that as a string inside your quotation marks. Then you want to put a comma, and then in a different string, you want to put WB. What does the WB stand for? Well, that means writing into binary. So there are lots of different languages that you can write files or data in, but binary is computer language, zeros and ones. And because of the way we've downloaded the data from the internet using requests, we want to make sure that when we save it as binary. So it kind of knows what to do with all that data. It doesn't think it's any string or anything like that. And then you say as file. Now, file doesn't mean anything in particular. It's just a variable. You could call it as data file or as, frog. It doesn't really matter. This is just a variable that we're using, and we're only using it for like 1 second. So as file. So as you've opened up this file, with opening this as a name for a file, we want to take the file and we want to write data to it. And what data do we want to write to it? We want to write our image data. So hopefully that kind of makes sense. That first line is telling it to create a file and open it up and call it file. And then it's saying to take all that data, image data, and cram it into that variable file, which is the opened file on your computer. So that's what that is all doing. And if we run that, hopefully there'll be no errors, and there aren't. And now, if you want to use your own image, you can do it at this point because we're just saving it to the same place. We are going to open that image back into memory to make sure it's saved properly, and also so we can see it. So here, we're going to use that matplot image library that I talked about at the beginning here, this second library. And we're going to create a new variable called image, img. And to do that, we're going to use the library impimg, however you pronounce it. And we're going to use its method called imread, which is to read an image file. And then all you do is you put in whatever you named your JPEG. I named it original image.jpg. And then underneath that, so now it's in memory, we want to display it. And we want to display it the same way that we displayed images, our figure yesterday. And that's doing plot, show the image. Which image do we want to show? We want to show img. So again, just to briefly recap, this line here is taking the data from that file that's saved on our hard drive, not the one we downloaded technically. That one's, we've saved that to our hard drive and we no longer care about it in memory. We're taking the one we put on our hard drive, opening that up, taking that data, putting it into the matplotlib library, and then displaying it. And if I run this bit, you will see it is the School of Athens, which was I thought had a nice number of individuals and scenery for us to kind of play around with today. There's a couple of things that you'll see on the sides of this image. What it does is it does give you your pixel count. So you can see it starts at 0, 0, and it goes over to 2,000, so 3,000 on the X, and it goes 2,000 down. Now this, for any mathematician in the room, is kind of frustrating for me because I really want it to be like Cartesian coordinates where you start at 0, 0 and move outward. But for various reasons, that's not how they do it. They start at the top left as 0, 0 and go to the bottom right. So you have to kind of think of it as stretching out like that, as opposed to like a normal set of Cartesian coordinates. It just takes a little, mental shift in how you think about it in order to think about how that image works. On the other hand, it may be more natural for some people if you say, it's, 10 down from the top and 13 to the right. That's sort of how you have to think about it. But it looks weird to me. That's all I got to say. So why does plotting image data not work? Yeah, so the IMG data is just a bunch of ones and zeros, and it's not been sort of put into a container that says at the beginning, this is an image file. So JPEGs have a little bit of code at the beginning of them that let you know how it's been formatted. And without that, Python doesn't understand that it's a JPEG, and so it doesn't know how to present it. Yeah, so actually this line right here is actually telling it to put that bit of data that says it's a JPEG. If you tell it to do it as a PNG or a GIF, it will put that tag that it is a PNG or a GIF, but because those ones and zeros weren't actually a GIF, it'll come out as gobbledygook as well. So it's just about matching it to the right language. So hopefully that works for everybody. Now we're going to do something quite basic where we're going to try to find out a little bit of information about this image right here. So what we're going to do is we're going to try to figure out what the color values in our image are. So what we want it to do is we're going to create two print commands. And these are going to tell us two different things. we're going to tell us what is the brightest RGB in the image and what is the smallest RBG in the image. And then we'll talk a little bit about RBG and how an image is constructed. So first, we just want to tell it to print the word max RGB value. And after this, we're going to put in this little bit of code. There's a lot of parentheses here. And basically the image max, oh, okay, I see what I've done here. Okay. So the image max here will look through the image data of IMG and it will figure out what is the largest number in there. An image is made up of RGB values, which go between 0, which is black, to 255, which is either full red, full green, or full blue. The way I've done this, I didn't have to type it this way. I could have also written max RGB value plus image max. And that would have done the same thing. And that might be something that you're more familiar with, where you put in a string and then you add or concatenate it, with another variable. But what you can do in Python is actually you can make a sentence or a string where you use numbered brackets, and you can just use it without a number if it's the first one, to essentially create a Mad Libs. So you put a sentence with my RGB value is this and that. And then it'll use the 3 values that you put in the format afterwards. So you don't have to use lots of concatenation and pluses. It doesn't really make a difference in this particular case because we only have the one variable, but it's a different way of doing it. And I just want to, if you see it when you look at other people's code, it's something that you might want to use. And in fact, I'll do the opposite for the minimum value, just so that you can see that it does show up basically the same way. And if I run this, cannot print a string. Okay, so it does not like that unless I put it into a string, which may be why I did this in the first place. Yes. Okay. So if I run these 2 bits of code, the maximum RBG value in our image is 255, which is white, which means there is a pure white or pure red or pure green or pure blue somewhere in this image. And the minimum value is 3. So what that means is at nowhere in this image is true black present. There's nowhere that is absolutely devoid of color. There's always a little bit of red or a little bit of green or a little bit of blue. Now, this is a pretty full color image, but if you were using a different set of image, especially something like satellite imagery or healthcare imagery or something like that, being able to be very fine and precise about what the color range, where that color means something, astronomy as well, that can give you a really good way of just looking at the image. But this is just looking across all of R's, all of G's, and all of B's. And maybe that isn't so helpful for your day-to-day image processing need. So instead, we want to tear this image apart. So what I'm going to do now is I'm going to create another file here, and you don't have to type any of this. This is just a visualization for you guys to have a look at. When you look at an image, it's really easy to think of an image as being like this. So you have a square, rectangle image, and each of these X's represents a different pixel in the image. And maybe this pixel is black, and this one is red, and then this one is green, what have you. But that's not, and this one is fuchsia, and this one is vermilion, and you have all these, millions of colors. Sorry, why don't we put the value in the format inside string? Oh, okay. So this formatting is basically formatting it to whatever format is required for how it's being used. So it's formatting it to a string automatically. Whereas here, it doesn't know what format it needs to be because it doesn't have that variable inside of a string already. So I had to manually tell it to turn to a string. Does that make sense? I probably should have explained that. Thank you for asking that question. That was an excellent question. Okay, so our image is made up of all these different pixels and they all have different colors, but the computer doesn't actually have a color for mauve or for vermilion or for really, really light candy, cotton candy pink. It has three numbers. It has red, it has green, and it has blue. That's all it has. So any color you see on a screen is partly red, partly green, and partly blue. And the combination of those three numbers forms the millions of colors that we can now have. And if you think back to the old days when I was a little kid, and you look at like the 8-bit systems for like Nintendo Entertainment System, they didn't have 255 values for their red, G, and B, so they had a much more limited color range because they could only do so many different kinds of red, so many kinds of green, and so many kinds of blue. That's why we have much better monitors here. And actually, if you go and you look at old image files you took or that someone else took in the 90s and you try to put them on a modern monitor, they will look really unphotorealistic, even if they seemed much more color real back in the 90s. And it's just because we've got used to how much color scale we can have on our new 4K or 1080 monitors. So this is not what a computer file for a data image looks like. What it actually looks like is a 3D image. Now, I can't actually draw a 3D image here in this box, but you're going to have to kind of play along with me. And what you actually have is, and we'll just pretend it's a 2x2 image here. So what you actually have is like 3 pieces of paper. And if you think of how newspapers are printed with the images and how they do different layers of ink, or even your computer printer where it's got like the cyan, the magenta, and the yellow, it does it in the same way. So it tells you a whole grid of reds, a whole grid of greens, and a whole grid of blues. And those 3 numbers together create the different color lights that you see on your monitor. So when you try to tell it where on the image to look, rather than giving a 2D coordinate, so, coordinate 100, 100, you have to give it a third coordinate as well. And that third coordinate is either 0 for red, 1 for green, or 2 for blue. So this is pixel 100, 100 on the blue channel. This is pixel 100, 100 on the green channel. And this is pixel 100, 100 on the red channel. So you have to kind of think of it as like 3 pieces of cellophane or 3 pieces of, translucent colored film, all put together to make your image. And because of that, you can actually examine your image in a lot more detail and manipulate it a lot, so long as you think sort of 3-dimensionally about it and kind of pretend it's in actual layers of those 3 color paints. So hopefully that little theoretical bit is useful for you. What we're going to do now is we're going to create a little program. And I know one of you came in after we did the function bit, but hopefully it will make sense as we do it. So what we're going to do is we're going to create a new program. And I'm going to call this channel. And what channel display is going to do is it's going to ask me a question. And that first question, sorry, you need to have that colon there to make it a function. That first question is going to be is which color channel do you want displayed? And this is a very simple question, and there's only going to be 3 answers that you have. So after it asks that question, it's got to put that data somewhere. So we're going to put that data into a variable X. Again, this is just a variable. You can name it whatever you want, but that's what we're going to call it. In fact, let's call it color, just so that we're not going to confuse ourselves. So what color do you want? The next thing it's going to do is it's going to run a little if-then kind of query on whatever color you did. So if color equals red, and notice that this is case sensitive. If it equals, if it equals, if it's exactly equal to red, then we want to use layer 0. So as I said before, the red layer is that 0 layer, blue is 1, green is 2. The next thing we want to say is, okay, if it wasn't red, go to the next thing. Elif, which means else if it, that's what it's kind of short for. Else if the color is equal to green, then you want to change the layer to 1. And if the color is blue, you want to change the color to 2. So that hopefully all makes sense. It's just asking you which color do you want, and then it's going to automatically choose 0, 1, or 2. Now, if you type in something that isn't exactly like that, you want to send an error message. So what you would do is you would say else, and else is kind of like the in all other eventualities. No matter what else you do, do this. Print, please try again. So it runs that little if-then statement to create that. The next thing we want to do is we want to create a color map. So I'll explain why that is in a moment, but we want to create a color map, and what the color map will be is whatever color the person or you has typed in, plus a lowercase s. So when it prints this image, regardless if it's the red channel or the green channel or the blue channel, it's going to try to make it colorful, which is going to like be very psychedelic, and you don't actually want for this program. So what you want to do is you want to say, make this reds, or make this greens, or make this blues, and it'll make it a gradient of just one of those colors. And because we've already made that our variable anyways, it's easier just to add the S at the end instead of having to retype it in. At this point, we're going to make our chart, and our chart is really simple. We want to name it, again, X plus space channel. So it'll be red channel. Oh, sorry, not X. I did change that. Color. Red channel, blue channel, green channel. We do want to show the image. And we do want to put the image in a certain way. So what we're going to say is we're going to put nothing. We're just going to put a colon, and that basically says all the pixels for X. And we're going to say all the pixels for Y. You could actually do it like this, and it would trim it down to just 0 to 100 on X, but we don't want to do that today. We want all of the X, all of the Y, and then we want to tell it which layer. And we already have that as a variable, so we put that there. And we want to put in the color map, or the C map, that we've done. So this CM will get changed to reds or blues or greens, whatever we do. There are dozens of color maps that you can find if you just search for matplotlib color map on Google, but these are really simple ones, and these are the ones we're going to use. Now this, if I load it into memory, again, it just goes into memory. It doesn't do anything until I try to run it here. So I'm going to run it and then we're going to talk through it and see if anyone has any questions. So which color do you want displayed? So if I type in red, I get an error because of course I do. Oh, what is it not like that? I am show. Oh, thank you. Sometimes you just cannot see your own typos. Let's try that again. And that's all it was. Thank you so much. That would have driven me absolutely crazy. So as we can see, we now have our School of Athens and it's entirely red. Now, this is a really important thing about this. This is not tinting the image red. This is not taking the image as it was and turning it into a red version of that image. What it's doing is it's taking just the red pixels. So everything that was green, everything that was blue is simply not being displayed. And that's why it looks quite almost inverted with lots of white in the background. If I run this program again and I do blue, you see the same thing. So this is all the blue that exists in that image. And if you want to run it one last time, you can have the green channel. And if you have combinations of green and red, blue and green that are not being displayed here, that's going to fill in a lot of the white that's quite missing. So this is how the image looks if you just take that one slice of the colors. So this program is actually just creating 3 different graphs for us without having to do it manually. In order to make that, this is really all we need, is just these 2 lines, and then filling in what color is and what layer is and what the color map is manually. But if you do it as a program again, I don't have to go back and change it every time. I can just change, my input variable. So we're going to do 1.5 more things, and then we're going to take a little break so you guys can rest your brains. So I've shown you our original image, which has lots of reds and greens and blues in it. And I've shown you what each of those channels looks like individually. And hopefully you've been able to follow along with me on this program. So what we're going to do now is we're going to see sort of optically what these different things do and how you can use Matplotlib to kind of adjust the colors in the image. And you might want to do this for all sorts of reasons. You might want to highlight a certain section. You might want to encase a certain section in boxes. And you don't want to just do that in a paint program because you want to do it programmatically. So maybe you have data that goes along with this image, metadata or paradata from somewhere else, and you want to use it to annotate or to somehow change the data. So the first thing I want to do is I want to open a new copy of our image. Now, this isn't strictly speaking necessary, but the reason I'm doing that is just to kind of clear memory to make sure nothing kind of interferes with what we're doing. So I'm going to write the exact same code that I used beforehand in order to create the data file, which is image equals npm imread original image. After that, I'm going to make 3 strips of light go across my image. So the first strip of light I'm going to do is on top of this image. So I'm going to actually replace pixels in this image. This isn't adding something to it in the sense of like putting a sticker on top. It's actually changing the pixels of the image. So in that image, you have the X coordinate, the Y coordinate, and the layer. And the layer I want to do is the red layer. And in that red layer, I want to put a band that goes from 50, which is 50 on the Y coordinate, down to 500. So it's going to be from about here to about here. And then on the X coordinate, I'm going to just leave that with a colon because I want it to do a strip all the way across. And this is going to add a red strip. And I'm going to set it to 255. Now, if I set it to 0, it'll turn all those pixels black. But if I set it to 255, it will basically turn the red up to full blast. So it will turn, something that's a little bit red to completely red. It'll make all the red red. And I'm going to do the same thing for the two other colors at different strips. So for the green strip, I'm going to start at 600 and go to 1050. And for the third strip, I'm going to go from 1150 to 1600. So this strip is red, this strip is green, and this strip is blue. And you can tell that because of the red channel, the green channel, and the blue channel here on this side. Now I'm going to show my image just like I normally do. And now you can see, and I'll just zoom in a little bit so that you guys can see a little bit better. We've got 3 strips. So again, I've not put any stickers. I've not put anything on top of the image. What I've done is I've taken every single pixel here, regardless if it was a 0, a 15, a 100, or 220, and I've turned it to 255 on the red channel. And I've done the same here with green, and I've done the same here with blue. And you can see that the red channel and the green channel, at least to my eyes, seem quite, they're changing the image quite significantly. The blue doesn't seem to be doing quite so much, which indicates to me that the blue was already up fairly high on a lot of these images. You don't see quite as much of a change. But sometimes being additive isn't really that helpful. You can't necessarily see with your naked eye what's going on. Sometimes subtracting works a lot better. And because I want you to see what subtracting does to the people as well as the objects, we're going to change this into vertical bars rather than horizontal. So you can just copy and paste if you want to kind of make your life a little bit easier. And this time, rather than turning the red, green, and blue all the way up, we're going to turn the red, green, and blue all the way down. And instead of doing horizontal stripes, we are going to do vertical ones. So basically, I've just switched the X and the Y coordinates around so that we get different kinds of stripes, that they go up and down instead. And if I run this program, this might seem a lot more familiar to you, the cyan, the magenta, and the yellow that you get in modern printers or you see in sort of modern print jobs. So this is what this image looks like if you strip every bit of red out of it. This is what it looks like if you strip every bit of green out of it. And this is what it looks like when you strip every bit of blue out of it. And if you look at it very carefully, that's very unhelpful, thank you. If you look at poor Diogenes, it's Heraclides actually, and Pythagoras down here, there is a huge difference in skin tone when you take all of the green out. And there's a huge difference in skin tone when you take all of the red out. But they look a little bit yellowy, a little bit jaundicey in these, but they don't look that bad. And that is why in old Hollywood, you have the blue screen when you're trying to do old replacement in images, because although it makes it look a little bit alien and a little bit off, it doesn't look as bad as if you use the other two colors and just remove those from the film process. It's a lot easier to remove the blue from the film and not have skin color look that bad. So again, hopefully these two images give you an idea of what happens when you turn the red, green, and blue channels all the way up, or you turn them all the way down. And you might want to do that in order to understand how an image is constructed, or you might want to do that just to help with your visualization and to make a creation. And again, you don't have to do bars. You can do really complex geometry and create shapes to kind of create, areas of your graph that have these sort of color images on it. Okay, so that was sort of the background of the analysis. Those are kind of the tools that you need to understand in order to develop your own tools later.